So hello everyone, welcome back to our channel. So till now we have discussed two videos related to we have started with the digital signal processing and one concept which is not through with respect to the syllabus, but I think that this topic is very important, that is discrete Fourier transforms. Okay, we have already started with that. Okay, we have not started with the algorithm part, that is the theoretical part, the derivation and all, because I think that if I start with that, it would be very difficult for you guys to understand the derivation, because if we solve the problems related to this first, right? So when we are discussing that algorithm or derivation part, which is very important, I'm not saying that that's not important. If we studied the problems, right, that would be very easy for you guys. Okay, so that's the first time solving the problems from these topics. Okay, in order to make you clear, so that's why till now in these two sessions we have discussed about DFTs. Okay, different kinds of problems, and with respect to magnitude and phase also we have solved two problems in the last session. So in this session we are going to continue with these problems only, two very important problems and different kind of problems. Okay, so please listen to this video very carefully. These two problems are a bit lengthy, but you would be understanding it very clearly because I am going to explain it in a clear manner. Okay, so please guys, like this video. Your like would be very beneficial for us. Please hit the like button, subscribe to our channel, hit the notification bell, it would be appearing in our channel logo. So please go through that, hit the notification bell, be regular to our channel. Okay, because this subject is very important. What and all problems I'm solving, right, please note it down, because these problems are very important. But I'm not assuring that these questions would be coming here, because this subject is only like that. Okay, mathematical concepts are there, but the questions are not repeated, it would be of different kind. So please do watch the video till the end, guys. Like the video, please. Your one like would be motivating us. Like the video, guys. So that's all. This was a brief introduction. Sorry to waste your time. So now let's start with the concept, with the first problem, that is calculate the 8-point DFT of the sequence 1 1 1 1. So now something is missing in this question. If you can find it out, what is that? So here they have given 8-point DFT, that is, we can say that the value of n, that is the length of the sequence, should be 8, right? But the sequence which they have given is this is basically x of n. Okay, if they don't give, we should be knowing that is x of n, because we are calculating the DFT, right? So they would be giving the sequence of x of n only. Okay, so here they have given 8-point DFT, but they have given only the length of the sequence as 1 1 1 1, only 4. So in order to make it so if they give like this, right, you should not be solving for 4-point DFT, you should be solving for 8-point DFT only. Okay, so whenever they give the length of the sequence here in the question and they give here the wrong length, what we should be doing is at the end of the set, right, we should be adding zeros. Okay, so our new set would be now 1 1 1 1. These are the 4 values. Then following that 4 zeros we should be adding. Okay, so now this is our x of n, where we have the length of the sequence. Now it is 8. 1 2 3 4 5 6 7 8. Okay, whenever they give these kind of problems, we should be knowing that at the end of the set we should be adding zeros. So in the question they would be mentioning what is the length of the sequence, and in the set they won't be giving the right sequence, so that in order to make it equal we should be adding zeros. So then the same thing we should be solving by using the formula x of k. So that is x of k, where n is equal to 0 to 7, since the value of n is 8. So that is n minus 1, that is 8 minus 1 is 7. X of n e power minus j 2 pi k n by 8, where k varies from 0 to 7. So here 2 1s are, 2 4s are. Then x of k is equal to, split this summation now, that is first term is x of 0 e power 0 plus x of 1 e power minus j pi k into 1 by 4, right, plus x of 2 e power minus j pi k into 2 by 4, that is 2 1s are, 2 2s are, so we would be getting minus j pi k by 2 plus x of 3 e power minus j, the value of n is 3, so 3 pi k by 4 plus x of 4 e power minus j pi k, because the value of n is 4, also we have 4 gets cancelled, we will be left with only minus e power minus j pi k plus x of 5 is equal to e power minus j, the value of n is 5, so 5 pi k by 4 plus x of 6 e power minus j 6 pi k by 4, that is 2 3s are 2 2s are, that is minus 3 pi k by 2 plus x of 7 e power minus j 7 pi k by 4, where k is equal to 0 to 7. So this is one single step here. Then what we should be doing is x of k is equal to, we can directly cancel some of the terms here, that is x of 0 1 2 and 3 are 1 1 1 1, and x of 4 x of 5 x of 6 x of 7 are 0. So these all the 4 terms would be getting cancelled out. Now we would be left with only these 4 terms. So now you would be arising with the question that if these 4 terms get cancelled, we have only x of 0 1 2 3, then what's the use of solving for 8 point? Okay, since these terms are getting cancelled, right, what's the use? But that's not the case, because we are substituting the values of k, if you observe here, from 0 to 7, not from 0 to 3. Okay, this is an 8-point sequence. We are substituting the value of k from 0 to 7, so that's why we would be getting different answer in the denominator part. Okay, 0 to 7, right? So that's the thing here, that's one change here. It is not that simple, so please don't make a mistake here. Okay, so now again simplify this. X of 0 is 1, so 1 into e power 0 is 1 again, plus x of 1 is also 1, we would be left with only this term e power minus j pi k by 4 plus e power minus j pi k by 2, right, plus e power minus j 3 pi k by 4, where k is equal to 0 to 7, right? So this is our final x of k value. Okay, now one by one you should be substituting for k is equal to 0 up to k is equal to 7. So this is a long procedure. For k is equal to 0 1 2 3 4 5 6 7, for all one by one you should be doing it. First is x of 0, that is 1 plus e power zeros only for everywhere, since it is getting multiplied by zeros. So x of 0 is equal to 1 plus 1 plus 1 plus 1, that is x of 0 is equal to 4. Okay, I will be doing it in a very quick manner because I don't want to waste time here. Next is for k is equal to 1. Okay, x of 1 is equal to 1 plus e power minus j pi by 4, where value of k we should be substituting it as 1, plus e power minus j pi by 2 plus e power minus j 3 pi by 4. All the values of k are 1, so x of 1 is equal to 1 plus, so again I have already kept this in the calculator here, this equation cos a minus I sin a. Okay, so in place of theta we have pi by 4, press calc button. I hope you know this, I have told you multiple times. Okay, pi by 4, the value is 0.707 minus 0.707 j. Okay, so this is the value, plus e power minus j pi by 2. So now pi by 2, the value is minus j, plus e power minus j 3 pi by 4, the value is minus 0.707 minus 0.707 j. Okay, so x of 1 would be 1 plus 0.707 minus 0.707 j minus j minus 0.707 minus 0.707 j. So plus and this minus would be getting cancelled here. So x of 1 we would be getting it as 1, then minus 0.707 minus j 0.707 j minus j and minus 0.707 j. If we sum it up, we would be getting 2.414 j. You can check it later. Okay, so this is our first term, x of 1, that is 1 minus 2.414 j. Similarly for k is equal to 2, now x of 2 is equal to 1 plus e power minus j pi by 2, because we have the value of k as 2, so that's why j pi into 2 by 4, so you would be getting it as a simplified. I have written as e power minus j pi by 2 minus e power minus j plus e power minus j pi into 2 by 2, so 2 will be getting cancelled. You will be left with e power minus j pi plus e power minus j 3 pi into 2 by 4, that is 2 ones are 2 2s are, we would be left with 3 pi by 2. Okay, so similarly x of 2 is equal to 1 plus, so here in this case we are having the value of theta as pi, by 2, so pi by 2, it is minus j plus pi, right, pi, it is minus 1 plus, we have here in place of theta we have 3 pi by 2, 3 pi by 2, so it is j, so we are getting 1 minus j minus 1 plus j. Okay, these all 4 terms would be getting cancelled here, and we would be left with x of 2 is equal to 0. Okay, so here we have solved for x of 0, x of 1, x of 2. Similarly, we should be solving for 3, 4, 5, 6, 7. Let's solve it quickly. For k is equal to 3, x of 3 would be 1 plus e power minus j 3 pi by 4, okay, plus e power minus j 3 pi by 2, in place of k I am substituting it as 3, plus e power minus j 9 pi by 4. I have written the simplified answers here, you can check it later. So x of 3 is equal to 1 plus, so now in place of theta we have 3 pi by 4, right, 3 pi by 4, that is minus 0.707 minus 0.707 j plus, so now 3 pi by 2, 3 pi by 2, that is plus j 9 pi by 4, 9 pi by 4, that is 0.707 minus 0.707 j. Okay, so this would be taking a lot of time, guys. I told you, right, we should be very quick in using the calculators. Okay, so like that we should be going on solving up to x of 7, so this would be taking a long time here, but still I am solving you guys in order to make you clear. Okay, so 1 minus 0.707 minus 0.707 j plus j plus 0.707 minus 0.707 j. If we solve this, our final value of x of 3 we are getting it as 1 minus 0.414 j. Okay, you can check it later. Similarly, for k equal to 4 now, that is x of 4 is equal to 1 plus e power minus j pi plus e power minus j 2 pi. Okay, I am writing the simplified version here. Okay, you can check it later, minus j 3 pi. So what is this equation? E power minus j pi k by 4, right, where the value of k is 4, so 4 will be getting cancelled, you will be left with k pi, j pi. Similarly, we have here minus j pi k by 2, where the value of k is 4, so 2 ones are 2 2s are, you would be left with minus j 2 pi. Similarly, e power minus j 3 pi. Okay, so I am not wasting time in writing that. So x of 4 is equal to 1 plus, so now in place of theta we have pi, so pi, that is again minus 1, then we have 2 pi plus 1, then we have 3 pi minus 1. Okay, so that is x of 4 is equal to 1 minus 1 plus 1 minus 1, that is these all terms would be getting cancelled, x of 4 is equal to 0. Okay, similarly now for k is equal to 5, this is an 8-point sequence, remember, so that's why this takes a lot of time. Okay, 1 plus e power minus j 5 pi by 4 plus e power minus j 5 pi by 2 plus e power minus j 3 pi k by 4. So 3 into 5, that is 15 pi by 4, right? So x of phi, that is equal to 1 plus, in place of theta we have now 5 pi by 4, that is 5 pi by 4, that is equal to minus 0.707 plus 0.707 j. Then we have 5 pi by 2, 5 pi by 2, that is minus j. Then we have 15 pi by 4, 15 pi by 4, that is 0.707 plus 0.707 j. Okay. Then again simplify this, x of phi is equal to 1 minus 0.707 plus 0.707 j minus j plus 0.0707 plus 0.707 j. Okay, so minus plus this would be getting cancelled. So if we solve this, our x of phi would be getting it as 1 plus 0.414 j. Okay, so this is our x of phi. Similarly, we are left with only two terms now for k is equal to 6 and k is equal to 7. That is x of 6 is equal to 1 plus e power minus j 3 pi by 2. Okay, since we have here j pi k by 4, that is j pi into 6 by 4. So 2 3s are 2 2s are, we would be left with 3 pi by 2. Okay, then plus e power minus j 3 pi plus e power minus j 3 6 are 18 pi by 4. Okay, so x of 6 here now 1 plus, so in place of theta again we have 3 pi by 2, 3 pi by 2, that is plus j. Then we have 3 pi, that is minus 1. Then we have 18 pi by 4, that is 18 pi by 4, that is minus j. Okay, so if we solve this, we get 1 plus j minus 1 minus j, plus j minus j gets cancelled, 1 minus 1 gets cancelled. So our x of 6 is equal to 0, right? Similarly, for k is equal to 7, x of 7 is equal to, so you are seeing, right, how much time I am taking. Yet I am solving very fastly, but still I am taking time because this is time consuming. Okay, so that's why you should be very quick in this. So this is the first term, that is minus j 7 pi by 4 after simplifying, minus j 7 pi by 2 plus e power minus j 3 7s are 21 pi by 4. So x of 7 is equal to 1 plus, so now in place of theta we have 7 pi by 4, so that is 7 pi by 4, that is 0.707 plus 0.707 j. Then we have in place of theta we have 7 pi by 2, 7 pi by 2, that is plus j. We have next 21 pi by 4, that is minus 0.707 plus 0.707 j, right? Yeah, again solve this, x of 7 is equal to 1 plus 0.707 plus 0.707 j plus j minus 0.707 plus 0.707 j. So this 4 would be getting cancelled. Our final answer after simplification is 1 plus 2.414 j. Okay, so like this we have got all the terms x of 0 up to x of 7. So now write those terms separately in one separate sequence of x of k. Okay, where the first value which you have got is 4, second value is 1 minus 2.414 j, next value is 0, then next is 1 minus 0.414 j, fifth value is 0, 1 plus 0.414 j, then it is again 0, 1 plus 2.414 j. Okay, so this is our final value of x of k, DFT, okay, for an 8-point sequence. Okay, so this one problem we have discussed for 8-point sequence, I told you, right, the problems are going to get complicated and very time consuming. For this problem only I have taken around 15 minutes. See, the length of the video is now only 20 minutes. So please go through this problem, guys, very important problem. Okay, whenever they ask 8-point DFT and they give the length of the sequence as 4, that many number of zeros you should be adding in order to make the length equal, and then solve, okay, by using the formula. Okay, so let's discuss one more kind of problem which is very interesting. So now let's see that problem. So this is the next problem here. Here this is simple, but very simple, guys. If you know the logic, you can solve it easily. So the question seems to be a bit tricky, where they have not given any sequence here in this question, as you can see. So without sequence, how to solve? So first, in order to solve, we should find this sequence of x of n. Okay, that is, the question here is find 4-point DFT of the sequence is not given. They have given x of n is equal to cos n pi by 4. Okay, so here now what we should be doing is, in the question first we should be checking for how many point DFT, that is 4-point DFT. So first write it as n is equal to 4. Okay, that is, in the summation part it tends from small letter n is equal to 0 to 4 minus 1, 3, right? In the if you check the formula for DFT. So here what we should be doing, from this equation we should be substituting the value of n from 0 to 3, so that we would be getting 4 different values of x of n. Whatever the values of x of n we get, write it in the set. Okay, that is, in that way you should be doing it. That is, first term is for small letter x of 0, that is cos of 0 pi by 4. Okay, so now similarly x of 1 for n is equal to 1, 2 and 3 I have written it. So here how to do this is, again in the cal we should use the calci here. The calci would be helping us now. That is, here they have given the equation cos of n pi by 4, but we don't have any letter n here to put in the calci. So instead of n we can directly write a, okay, which in the previous method which I have told you, right, for cos a minus I sin a. Okay, see, similarly here what you should be doing is cos of, in place of n write a, that is alpha and this sign a, then pi by 4. Okay, right, like this cos of a pi by 4, press calc, it would be asking the value of a. We know that the value of a or the value of n tends from 0 to 3. Okay, we should be substituting the value of a as 0, 1, 2, 3, and whatever the answer we get, we should write it down in the sequence. So first is for x is equal to n is equal to 0. So a first value is 0. See, the answer we got is 1. So first answer is 1. Okay, the next answer, the next value of n is 1. So press equal to the value of a. It asks the value of a. Press 1. Root 2 by 2, that is 0.707. The next value is 2. It is 0. The next value is 3 minus 0.707. Like this we got all 3 values. Put it in the separate sequence of x of n, that is 1, 0.707, 0, minus 0.707. Okay, so like this you should be finding first the input sequence, that is x of n, in order to find the DFT. So now we got the sequence. Then now the same thing, what to do is we should be calculating for DFT x of k by using this sequence, 4-point DFT. So let's quickly solve it now. So here I have written the formula, n tends from 0 to 3, e power minus x of n into e power minus j 2 pi k n by 4. The value of n is equal to 4. That's why 2 1s are 2 2s are, where k tends from 0 to 3. Okay, so next step is x of k is equal to split the summation x of 0 e power 0 plus x of 1 e power minus j pi k into 1 by 2. So e power minus j pi k by 2 plus x of 2 e power minus j pi k into 2 by 2. So 2 gets cancelled, we would left with only minus j pi k plus x of 3 e power minus j 3 pi k by 2, where k is equal to 0 to 3. Okay, this is the first step. Then substitute the values of x of 0, x of 1, x of 2 and x of 3. So you can see that x of 2 value is 0, so this whole term would be 0. We would be left with only these 3 terms, that is x of 0 is 1, so 1 into e power 0 is 1 plus x of 1, the value of x of 1 is 0.707 into e power minus j pi k by 2. So this cancels. So x of 3 is minus 0.707 into e power minus j 3 pi k by 2, where k is equal to 0 to 3. So this is the equation which I have got here now. So now for this equation we should be splitting the value of k from 0 to 3. Okay, so quickly let's solve it. For k is equal to 0, x of 0 is equal to 1 plus 0.707 into e power k is 0, so this whole term would be 0, minus 0.707 e power 0. So we can directly cancel these two out. So we would be left with x of 0 is equal to 1. Similarly for k is equal to 1, x of 1 is equal to 1 plus 0.707 e power minus j pi k by 2, that is 1 by k is value is 1, minus 0.707 e power minus j 3 pi by 2. Okay, so x of 1 is equal to 1 plus 0.707 into the value of pi, the theta is now pi by 2. So now put pi by 2, that is minus j minus 0.707 into 3 pi by 2, right? 3 pi by 2, it is plus j, that is 1 minus 0.707 j minus 0.707 j, that is x of 1 is equal to 1 minus 1.414 j if you simplify. Okay, so this is the value of x of 1. Similarly for k is equal to 2, that is x of 2 is equal to 1 plus 0.707 e power minus j pi into 2 divided by 2, so e power minus j pi minus 0.707 e power minus j 3 pi after simplification. So x of 2 is equal to 1 plus 0.707 into the value of theta is now pi, put pi, minus 1 minus 0.707 into 3 pi, right, again minus 1. So we would left with x of 2 is equal to 1 minus 0.707 minus into minus plus 0.707, so that is x of 2 is equal to 1. Okay, similarly for k is equal to 3, x of 3 is equal to 1 plus 0.707 into e power minus j 3 pi by 2, okay, minus 0.707 e power minus j 3 into 3 9 pi by 2. So x of 3 is equal to 1 plus 0.707 into the value of theta now here is 3 pi by 2, 3 pi by 2, that is plus j minus 0.707 into we have 9 pi by 2, 9 pi by 2, that is minus j. X of 3 is equal to 1 plus 0.707 j, again minus into minus plus 0.707 j. So our final value of x of 3 is 1 plus 1.414 j. Okay, like this we have found the values of x of 0, x of 1, x of 2 and x of 3. So finally write the set of x of k, that is first value is 1, next value is 1 minus 1.414 j, third value is again 1, fourth value is 1 plus 1.414 j. Okay, so like this we should be solving for DFT whenever they have not given the sequence, that is they won't be giving any sequence, that is x of n, they would be giving it like this. We should be first seeing for the value of n how much values they are given, from that apply to this formula from n tends to 0 to n minus 1, that many values we should be adding, and whatever the values of n we should be substituting in that equation, and we should be getting the values of x of 0, 1, 2 up to x of n, then separately write it in a set and solve for DFT. Okay, so this is the solution here for this problem, so please note it down. So this video is has gone a bit lengthy, but what to do guys, these kind of problems are only like that. What to do, it would be taking a lot of time, so that's why it has crossed now 30 minutes. So that's all guys, I won't be wasting your time. So please like, share, subscribe guys, hit a like button for our efforts. So we'll see you in the next video. Thank you.